In this question, we're told that L is a circle with the equation x squared plus y squared equals 4. The point P, which is 3 over 2 root 7 over 2, is a point on L, and we need to find the equation of the tangent to L at the point P. Now the equation of the circle is given to us in the form x squared plus y squared equals r squared. And now when a circle has the equation x squared plus y squared equals r squared, the centre of the circle is always the origin. And now since we have x squared plus y squared equals 4, we can say that the radius r is equal to root 4, which is equal to 2. So now we can represent the information given to us using a diagram. So we've drawn a diagram to represent the circle x squared plus y squared equals 4. And so we can see that the centre of the circle in our diagram is the origin, which is 0, 0, and that the circle has a radius of 2. Now we're going to imagine that point P is over here. And so we'll label this point P. We're asked to find the equation of the tangent to L at the point P. And so we can start by using a different coloured pen in order to draw on this tangent. And so we need to find the equation of the purple line, but we don't currently have enough information to do this. What we can start by doing is to find the equation of the line OP, which we've drawn in green. So the gradient of the line OP is given by the change in y divided by the change in x. P is equal to 3 over 2 root 7 over 2, and the origin O is equal to 0, 0. And so to find the gradient of OP, we do the change in y, which is root 7 over 2 take away 0, all divided by the change in x, which is 3 over 2 take away 0. And so we end up with root 7 over 2 divided by 3 over 2, and we get an answer of root 7 over 3. But this is the gradient of the line OP, which is the green line in our diagram. And we need to find the gradient to the tangent to L at the point P, which is shown by the purple line. Now we know that the green line and the purple line are perpendicular to one another. And so we can use the gradient that we found of the line OP to find the gradient of the tangent. So we'll call the gradient of the tangent MT, where M represents the gradient and T refers to the tangent. Now when two lines are perpendicular, their gradients multiply together to give an answer of -1. So we can say that MOP multiplied by MT, which means the gradient of the line OP multiplied by the gradient of the tangent, is equal to -1. So we can say that root 7 over 3 multiplied by MT equals -1, and therefore MT is -1 divided by root 7 over 3, which is equal to -3 over root 7. Now that we find the gradient of the tangent, we can find the equation of the line by substituting in the point P, because the tangent passes through the point P. So we can say that y equals mx plus c. The y coordinate is root 7 over 2. M is equal to -3 over root 7. And then x is equal to 3 over 2. And we need to find c. So we can simplify this. We say root 7 over 2 is equal to -3 over root 7 multiplied by 3 over 2, which is -9. And so taking the -9 over 2 root 7 to the other side, c is equal to 8 over root 7. So we found that m is equal to -3 over root 7 and c is equal to 8 over root 7. And so the equation of the tangent to L at the point P is given by y equals -3 over root 7 x plus 8 over root 7. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. The first mark is for a method to find the gradient of the line OP, which we found is equal to root 7 over 3. And now the second mark is for using this value in order to find the gradient of the tangent, because we know that the tangent is perpendicular to the line OP, and so we found that the gradient of the tangent is equal to -3 over root 7. And finally, the third mark is for substituting point P into the formula y equals mx plus c in order to find the value of c and to get a final answer of the equation of the tangent to L at point P, which is y equals minus 3 over root 7x plus 8 over root 7, allowing us to get the third and final mark needed to get full marks for this question.